In this video, I'm going to solve the weekend homework 16. First question, which points does the observer at point G see? First, we take the symmetry of the observer and then draw two lines to the edge of the mirror. Now, the area between these two lines is my view of vision. So N and M are at this point, so the observer will see N and M. Here again we take the symmetry of the observer according to the one at the left. We take two lines to the edge of the mirror. So this region is where the which points the observer can see. So from this mirror, K, L, and M points are observed. And do the same for the second mirror. Take the symmetry according to the mirror and draw two rays to the edge of the mirror. And this area is the side of view of the observer. So from this mirror, the observer can see L, K, and M. In this one again, we take the symmetry of the observer, draw two lines again to the edge of the mirror, and you see that Y and Z are between the rays, so the observer can see Y and Z. Take the symmetry according to the mirror, draw two rays to the edge of the mirror. You see here that this ray is passing over the M, so you can see M, and L is between the rays, so L. The second one, draw the image formed in the given plane mirrors. We take the symmetry of X. In order to take the symmetry, we take 2 points at the bottom and top and draw a perpendicular line. So go on, and this point is the symmetry of this point. And then do the same thing for the second point. Be careful, these lines should be perpendicular and these distances should be equal. So the symmetry of the second one is here. And then I complete the points and draw the image of X. Now take the symmetry of the writing. So you got it. I-T-T-O-G. In fact, you have the reverse of it. Three, which one or ones of the observers located at the points X, Y, and Z see the whole wall KL by just looking at the mirrors? It is not easy to take the symmetry of X because we don't have space here, so take two rays, one to this edge, it is perpendicular, so reflected back on itself, and the second one to the other edge, and it is reflected with the same angle. So this area is where the observer can see. So you see that you only see the half of the KL. And in the second one, I take the symmetry of the observer Y, draw two lines to the edge of the mirror, and this area is where the observer can see. So you see that you can see all of the KL, so it is okay. And the third one, take again the symmetry of Z, draw two lines to the edge of the mirror, and this area is where the observer Z can see. So you see that it is all in the vision. In this question, we're going to take the image of the picture according to the edges AB, BC, CD, and AD. First, let's make for CD. We take the symmetry as like this, images. So let's do for AB. It is, you see, also the same images. So let's take the symmetry of picture to BC. It will be like this, and here it will be like this. So horizontally, the letters I and E doesn't change because when you split it in horizontally, it is symmetric, and in vertically, the I, M, and A doesn't change because when you take vertically, these letters are symmetric. Now a ray is given here with an incidence, angle of incidence 60 degree. It will be reflected with an angle of reflection 60 degree. It is reflected from the second to the third, and like this from the third one. Now I'm going to put the angles. If this is the angle of refraction from the first mirror is 60, then this angle will be 30 degrees centigrade. As this is 45, this will be 15 degrees centigrade. I draw a normal which is perpendicular to the mirror too. So this angle will be 75 degree as the angle of incidence in a plane mirror 2. So it will be equal to the angle of refraction. Now this will be 15, as this is also 45, this will be 30. Draw a normal. So this will be 60, which is the angle of incidence of the mirror 3. So this will also be 60, angle of refraction of the mirror 3. So you see that we have 1, 2, 3 reflections. The angle of incidence I1 is equal to 60. The angle of incidence I2 is equal to 75. The angle of incidence I3 is equal to 60. The angle of refraction 1 is 60. The angle of reflection 2 is 75. And the angle of reflection R3 is equal to 60. Now we have some light sources inside the spheres X and Y, and the illumination at the surface of the spheres are equal, so we are going to find the ratio I1 over I2. Illumination is equal to the light intensity over the distance squared. As the illuminations are equal, then I can say EX is equal to EY. So here the light source I1 illuminate the surface with a radius R1 square is equal to I2 over R2 square. It is also given in the question that R1 over R2 is equal to 3, so you can take R1 as 3 and R2 as 1. So put these values inside this equation. I1 over 3 square is equal to I2 over 1 square. So I1 over I2 is equal to 9. In this question, we are going to find the ratio of the illuminations and the luminous fluxes. Now, illumination is equal to the light intensity over distance square. So, Ax is equal to I over R square. Ay is equal to 4i over 2r square, which is equal to 4r square. So it will be equal to 1. The luminous flux is equal to 4pi for a full sphere, as x and y are full spheres, so I can use this formula. So the flux of x is equal to 4pi. The flux of y is equal to 4p times the light intensity 4i. So the ratio is equal to 1 over 4. In this question, this angle is given as 30 degree. So this is equal also 30 degree. Then this is 60. From the right triangle, this is 30 degree. So theta 2 is equal to 60 degree. So this angle is equal to I1, the angle of incidence to the first mirror. This is the angle of incidence, angle of reflection of the first mirror. This is angle of incidence to the second one, and this is angle of reflection to the second one. Here we are going to draw the shadow formed on the screen. We draw lines tangent to the objects. Now you see that here a shadow of K is formed. You can find the ratio of, if let's say the object has a diameter of R. I'm going to draw two triangles. This triangle is similar to this triangle. So from the similarity, R over this distance should be equal to D over this distance 3D. So you can say that the unknown diameter of the shadow is equal to 3R. Now do the same thing for L. I draw two lines tangent to L. So you see here a small shadow is formed because L is away from the light source. As you get away from the light source, the shadow, the dimension of the shadow decreases, gets smaller. So let's take the ratio here also. This has R and this is unknown. So here this triangle I have shaded is similar to this triangle. So from the similarity, R over the unknown diameter should be equal to 2D over 3D. So the unknown diameter is equal to 3R over 2. So you see that it is a small shadow. So I can draw, we have a big shadow upside and a smaller one at the bottom of it. Let's find which points can be seen by the observer O. Take the symmetry of O according to the first mirror and then draw two lines to the edge of the mirror. So you see that it is passing over L and K is in between the two rays. So from the first mirror I can see the points K and L but not M. So do the same thing for the second mirror. Take the symmetry of the observer, draw two lines to the edge of the mirrors. So you see that it is passing through K and L is between the two rays. So from this mirror, KL is observed. So from the both of the mirrors, you observe K and L. The objects K, L and M are in equilibrium as in the figure. If the volume of the objects are equal, they have the same volume. So first I'm going to compare the buoyant forces applied on the objects. You know that the upthrust force is equal to density of the liquid times the immersed volume times the G. They are in the same liquid, so the density of the liquid is the same. You see that all of the M is immersed, all of the L is immersed, but this part is immersed, so the immersed part of K is smaller than V. So as buoyant force is directly proportional to the immersed volume, L and M has same upthrust forces bigger than K. Now I'm going to compare mass and density. You see that the M sinks, so the density of M is bigger than the density of the liquid. L is hanged in equilibrium, so it is density is equal to the density of the liquid. K is floating, so the density of K is smaller than the density of the liquid. So the M is bigger than the L, it is bigger than the K. For the mass is equal to density times volume. As they have the same volume, so mass is directly proportional to density. So we have the same relation. M is bigger than L is bigger than K. Now here we have an object with a weight of 40 Newton. It is hung by a string as in the figure. The tension in the rope is 25. So the upthrust force is equal to here 40 minus 25, it is 15 Newton. We have two portions, let's say this one V, so the volume of the object is equal to 2V. So upthrust force is equal to density of liquid times immersed volume times G. Now I'm going to put the values. Upthrust force 15 Newton. As it is in Newton, I have to take the density as kilogram per meter cube, which is equal to 1000 kilogram per cubic meter. So 1000 times V times 10. So the volume of the object is equal to 15 times 10 to minus 4 cubic meter. Now we know the weight of the object is equal to mass times G. It is 40 Newton. The mass is equal to density times volume. So density of the object is asked. The volume of the object is equal to 2V, which is equal to 30 times 10 to minus 4 cubic meter, and times G10. So here I have the density of object 4 over 3 times 10 to 3 kilogram per cubic meter, which is equal to 4 over 3 gram per cubic meter. The last question, identical objects. Identical objects means they have the same weight. So this has a weight G and this has a weight G. K is floating, so the upthrust force is equal to G. Y is in equilibrium, so the upthrust force is again equal to G. One compare the densities of the liquids X and Y. You see that the object is floating in X but in equilibrium in Y, so that means that the density of X is bigger than the density of Y. We're going to compare the buoyant forces. You see that they are equal. Increase in mass of the container. Now, what I put, the change or the increase in mass is equal to, you know, that the mass in minus mass out. What comes in, the G comes in. But some water will be overflown. So this overflown water has a mass or weight equal to the upthrust force. As upthrust force is equal to G, then there will be no increase in mass. So it is the same in both of them. There is no increase in mass. Compare the mass of the liquid overflown. The mass of liquid overflown or the weight of liquid overflown is equal to upthrust. So they have the same upthrust. So it is also the same for both of them, which is equal to the updraft, which is equal to the weight of the objects.